This video briefly covers some of the main ideas about center of mass. The center of mass can be thought of as any point on an object which, when held, will balance. So like we did in class, if we have two equal masses on a rod, the rod will balance in the middle, and this is because the center of mass is in between the two masses. If one of the masses becomes a little larger than the other, the center of mass is going to shift towards the larger mass. The equation for the position of the center of mass is just simply every single mass times its position added up divided by the total mass. And the equation for the velocity of the center of mass is simply just every single mass times its velocity divided by the total mass. One other important thing to note about an object's center of mass is that if there are no external forces acting on the system, then the center of mass will travel at a constant velocity. Let's do a problem. A 58 kilogram woman and a 20 kilogram child sit on a seesaw that is 3.5 meters long. Where is the center of mass? So we know that our equation for center of mass is the sum of every mass times its position and then divide by the total mass. So if we were to place a number line along the seesaw, we are going to assume that the child is at the origin. And this means that the woman is going to be at 3.5 meters. So then we can solve, and we see that the center of mass is 1.94 meters. So this means that the center of mass is 1.94 meters away from the origin, or in other words, 1.94 meters away from the child. Let's do another problem. Two boxcars are in a shipyard. They collide and stick. Calculate the velocity of the center mass before and after the collision. So the diagrams on the left show us the different masses and velocities of the boxcars. So let's calculate the velocity of the center of mass before the collision. To do this, we simply multiply the velocity of each boxcar by its mass and divide by the total mass. And we see that the initial velocity of the center of mass is 1.09 meters per second. Now let's calculate the velocity of the center of the mass after the collision. We once again multiply the masses by their velocities and divide by the total mass. And once again, we find that the velocity of the center of the mass is 1.1 meters per second. So notice how the velocities of the center of mass are almost identical before and after. And this is because there were no external forces acting on the system, so therefore the velocity is going to be constant.